short subject on the meteoric impacts on Earth, the Moon, and Mars. Billions of years ago, when Mars and Earth were forming within the cloud of dust and gas that surrounded our young sun, both planets' surfaces were continually being bombarded by asteroids and comets that left spectacular scars in the form of craters on their surfaces. Fortunately for all of us here on Earth, our skies today have become much calmer, but occasionally Earth encounters rocky fragments, wandering aimlessly through interplanetary space. If they are sufficiently massive, these rocks enter our atmosphere, leaving a fiery trail, then landing on the surface of the Earth in the form of a meteorite. Rare and highly sought after, these celestial rocks are a source of valuable scientific information to scientists and to the private collectors within the general public. They are a fascinating piece of our solar system to hold in one's hands. Obviously, meteorites do not fall exclusively onto planet Earth. These rocks from outer space also fall on Mars, the Moon, Mercury, and even Venus. The NASA rovers we have sent to Mars have encountered them from time to time during their exploration of the Red Planet. The rovers stop to take photographs and carry out a few chemical analyses before quickly continuing on their way. The NASA rover's mission priority is first and foremost to study Martian rocks, with meteorites being regarded simply as amusing curiosities. When a meteor crashes into our planet, it first strikes the dense layers of Earth's atmosphere at incredible speed, more than 22,000 miles per hour. Air friction causes the meteor to heat up considerably, at which point most of them that do come falling through Earth's atmosphere are completely vaporized before they even reach the ground. The descent of an impacting meteor, which is called a meteorite when it reaches the ground, produces first and foremost what is known as an acoustic shock, waves that propagate ahead of it and then striking the ground violently, leaving a visible trace on scientific instruments known as seismographs. If the meteorite is not totally consumed during its passage through the atmosphere, part of it may reach the surface and blast out a crater. The energy released by the collision then creates new shock waves that differ from those generated by the atmospheric blast, but which are just as interesting to intercept and study. However, the mechanisms described varies with the presently existing nature of the other planetary bodies within our solar system. With having no atmosphere at all, the Moon provides no resistance whatsoever to falling meteorites, which arrive intact on the surface, striking the lunar regolith with full force. The network of seismic instruments left on the Moon by the astronauts from the Apollo missions has detected thousands of meteorite impacts, helping to draw a clear picture of the inner depths of Earth's natural satellite. With a very thin atmosphere of carbon dioxide and only 6 millibars of pressure, which is 200 times less than that of the Earth's atmosphere, the situation with Mars's atmosphere is somewhere between that of the Earth and the Moon. On Mars, the fall of a meteorite is accompanied not only by a shock wave that propagates through the air, but also by a cluster of seismic waves related to the surface impact itself and the related excavation of a crater. The small impacts that create craters of just a few tens of feet in diameter are statistically far more numerous than the impacts that can hollow out a crater, say, over 300 feet wide. An impact capable of making a crater on Mars over 300 feet in diameter occurs roughly every 10 years. By being able to document the rate of impacts currently striking the surface of Mars helps planetary geologists to refine the dating of the Martian terrain. As a general rule in planetary geology, the older the terrain, the bigger and more numerous craters that terrain will be found to contain. Lastly, the inherent danger of falling meteorites for future crew missions to Mars will be better quantified. Thank you for watching this video, and I hope you have enjoyed the subject on planetary geology about meteoric impacts on the Earth, Moon, and Mars.